All right, today we're going to talk about section 4, which is complex numbers. And I know everybody loves complex numbers. So we'll start by talking about the imaginary number I. I is equal to the square root of -1, which means I squared is equal to -1. So if b is a positive real number, then the square root of -b can be rewritten as I times the square root of b. Basically, to get that negative out of the square root, we take the I out front. Complex numbers are a plus bi, where a and b are both real numbers. Real numbers are a subset of the complex numbers, so technically every real number is also a complex number. It just has a 0 for b. And then we have a complex conjugate, which is a minus bi. All you do is change that center sign on the I term. So let's rewrite this in the form a plus bi. So -50. Well, we can break this apart into a -1 times 25 times 2. The reason for that break apart is because the square root of -1 is I. We know the square root of 25 is 5. And the square root of 2 is just on its own. Now the proper form for this, if you have a number, an I, and a square root as one piece, you put the number, the I, and then the square root part. If I'm doing the square root of -6 times the square root of -15, we need to simplify it with i's first. I can't just multiply -6 times -15 and call it a day. No. So we need to separate this into -1 times 6, which the square root of -1 is I, the square root of 6 is just the square root of 6. And then we have our 15. We make it -1 times 15. The square root of -1 is I. 15 is not a perfect square and doesn't have any perfect square factors. So now we multiply. I times I is I squared. The square root of 6 times the square root of 15, well, I can multiply those together. We get the square root of 90. Well, lucky for me, I know that I squared is -1. Big one there. I squared equals -1. Don't forget that. And the square root of 90 can be broken apart into 9 times 10. And the square root of 9 times the square root of 10, well, the square root of 9 is 3. The square root of 10 is stuck. Multiply -1 times 3, I get -3 square root 10 for that whole thing. If you just multiplied right away, you would get the square root of 90, and you wouldn't have that negative in your answer. All right, then we don't like square roots in the denominator, so to get rid of a square root in the denominator, we multiply it up. But I also now have some complicated stuff in the numerator. I have a -1 times, well, let's see, how could I break apart 63? 9 times 7, right? And I still have the square root of 7 in the top. The bottom I created to just be 7. All right, the square root of -1 is I. The square root of 9 is 3. Square root of 7 times square root of 7 is just 7. All over, still that 7 in the denominator. Well, I can cancel these 7's out, and that leaves me with 3 times I, or 3i. For the next one, let's simplify our square root of -125. Let's just do that off to the side here. I know I want to pull out that -1, and I know 25 is a perfect square. That times 5 makes 125. So I take each square root individually. Square root of -1 is I, square root of 25 is 5, and the square root of 5 is stuck. So really that is 5i square root 5. So we'll rewrite our original problem. -10 plus 5i square root 5 over -5. Well, now, just like with quadratic formula, all three of these pieces can be divided by -5. So I get +2 minus 1i square root 5 over +1. There's my final answer, 2 minus I square root 5. So let's try a few more here. the square root of negative 16. Well, remember I break apart that. The square root of 16 is 4. The negative 1 gives me an I. 56 gets a little more complicated. I need to turn it into a negative 1 times 4 times 14. Okay, 14 can't be broken down anymore. The square root of 4 is 2. The square root of negative 1 is I. And the 14 stays stuck. If I take square root of 7 times the square root of negative 21, I want to simplify the square root of 21 first. So I have the square root of 7 times I square root of 21. And then I can multiply my square roots together. So I get I square root 147. But I happen to have noticed that I had a 7, and 7 goes into 21, so I'm pretty sure 49 is a factor of 147. I'm pretty sure it's times 3. The square root of 49 makes us 7, I square root 3. And for this last one, the square root of negative 12 can be rewritten as, I know 4 goes into 12, right? Square root of 12 can be 4 times 3, which is 2 square root 3. I just stick an I in there also, 2I square root 3 divided by negative 2. Divide everything by negative 2, I get negative 4 plus I square root 3 as my final answer. All right, other powers of I. Just for simplification purposes, we never leave I to a power. I is the square root of negative 1. It can't be changed, it's just I. But I squared, if I square the square root, I get negative 1. I cubed, well, I have I squared times I, so I have negative 1 times I, which is just negative I. I to the 4th power, I could make I squared times I squared, which is negative 1 times negative 1, which is just positive 1. And then it repeats. I to the 5th power is I. I to the 6th power is negative 1. 7th power, negative I. 8th power, 1. On and on and on, forever. Never leave a higher power of I. So if I simplify, I to the positive 13th power. Well, I to the 1st power is I, negative 1, negative I, 1. I, negative 1, negative I, 1. I, negative 1, negative I, 1. I. It is equal to just I. Negative 19th power, we're going backwards. So, I personally like to just have them listed out here. So, I to the 1st power there. 0, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Boom. I to the negative 19th power is equal to just I. You could also add 4 or subtract 4 until you get a remainder that's either 1, 2, 3, or 4. So I to the 64th power, I don't want to count through those all, but I noticed that 1, 2, 3, 4, right? If I subtract 4 over and over and over and over, I get to 0. Well, I don't want 0. So I get left with 4. I to the 4th power is 1. There we go. Negative 30. I want to add 4. Add 4, add 4, add 4, add 4. I'm going to end up with, let's see here, I to the 2nd power. So the answer is just negative 1. All right, for operations with i's, if we are adding or subtracting them, we treat them just like a variable. So in this case, I need to distribute the subtraction into this term and then combine like terms. So I have 8 minus 3i minus 2 minus 4i plus 5 plus 7i. Add my constants. 8 minus 2 plus 5 is 11. Add my i's. Negative 3, negative 4i plus 7i is 0i. My answer is just 11. For multiplying, we are just going to FOIL. So first is negative 15. Outside is positive 5i. Inside is positive 12i. Last is minus 4i squared. We combine our like terms, right? Negative 15 plus 17i. But then remember that I squared equals negative 1. So this term here is actually negative 4 times negative 1, which is positive 4. Now we have another set of like terms to combine. Negative 11 plus 17i. No i's to higher powers can be left in a problem. If I need to square, remember, you never, ever distribute a square into adding and subtracting. We need to write the problem twice and FOIA. 4 times 4 is 16, minus 28i, minus 28i, plus 49i squared. Well, combine my negative 28i's, I get negative 56i. Remember that I squared is negative 1, so that becomes minus 49. Now combine my new like terms, negative 33 minus 56i is the final answer. And then for 10 minus 3i times 10 plus 3i, notice that these are the complex conjugates. One's a plus, one's a minus, otherwise they're exactly the same. Let's see what happens when we multiply them. We get 100 plus 30i minus 30i minus 9i squared. Well, the 30i's cancel each other. I squared is negative 1, so that becomes plus 9. I get just 109. When you multiply a complex number by its complex conjugate, you'll get just a real number. No i's anymore. And now, when we are dividing complex numbers, remember that I is the square root of negative 1. We can't have square roots in the denominator, so we have to deal with that. The trick to this is that you multiply the numerator and denominator by the same thing. That thing happens to be the complex conjugate of the denominator. So 1 plus 5i is what we'll multiply by. In the numerator, we FOIL. 2 times 1, 2 times 5i, 3i times 1, 3i times 5i. In the denominator, we FOIL. 1 times 1, 1 times 5i, negative 5i times 1, negative 5i times 5i. Boom. We simplify. 2 plus 13i minus 15 over 1 plus 25 makes negative 13 plus 13i over 26. But wait, one more step. I can divide everything by 13, giving me negative 1 plus I over 2. Technically, that is not the standard form of our imaginary number. I'd want to say negative a half plus 1/2 I for standard form. All right, for the next one, to get that I out of the denominator, we multiply by the complex conjugate of the denominator, which is 2 minus 7i. FOIL the numerator, I get 10 minus 35i plus 12i minus 42i squared. Over, multiply out the denominator, 4 minus 14i plus 14i minus 49i squared. Combine like terms, I get 10 minus 23i plus 42 over 4 plus 49. I have 52 minus 23i over 53. Can't do anything with it. That is my final answer. So a few for you to try out here. Just kidding, those are the ones we just did. Ignore those. The reason for this is that we want to solve our equations with complex numbers also. So to solve with quadratic formula, the first step is to get it equal to 0. So I would add the 13 over. And now I plug in my numbers. X is equal to negative b, so positive 6, plus or minus the square root of b squared minus 4ac all over 2a. And now I simplify 6 plus or minus the square root of 36 minus 52 over 2. We can tell right now that we're going to get a negative inside the square root, but that is fine. Negative 16. And lucky for us, we already know the square root of negative 16 is 4i. And then we can divide everything by 2. So x equals 3 plus or minus 2i. There we go. For the next one, same start to it, get it equal to 0. I have 8x squared minus 12x plus 5 equals 0. And now go straight to quadratic formula. Opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. We have 12 plus or minus the square root of 144 minus 160 all over 16. I get 12 plus or minus the square root of negative 16 again. Apparently I really liked the negative 16 because we have 12 plus or minus 4i over 16. Here our denominator will not go away, but we can divide everything by 4, giving me 3 plus or minus I over 4. We can also complete the square and use square root property in this type of problem. So the first step, get the x's alone, subtract that 97 over. We have 4x squared plus 8x equals negative 92. Well, I have a coefficient on the x squared still, so I'm going to divide everything by 4. I have x squared plus 2x equals negative 23. We're going to add something on both sides. Half of 2 squared is 1. So we have x plus 1 squared equals negative 22. We square root it. Gives me x plus 1 equals positive or negative I square root 22. Subtract the 1. We get x equals negative 1 plus or minus I square root 22. And for this last one here, same start, we subtract 31. I get x squared minus 4x equals negative 39. We're going to add the same number to both sides. Half of 4 squared is 4. This will factor into x minus 2 squared equals negative 35. We'll square root both sides. Gives me x minus 2 equals positive or negative I square root 35. And then add the 2. X equals 2 plus or minus I square root 35 for our final answer there. All right, you'll have a bit of practice now on all of this.